So system classification problems. The first one is whether it is static or dynamic. So we have to following given the functions that should be static or dynamic. So we already know what is static, what is dynamic. Dynamic static means it's a memoryless, and memoryless means it doesn't have past future values. It is static. If it is have future and past, that is called as dynamic. So y of n is equal to x of n x n minus 4. So this is how past values. So the system depends upon dynamic, and the output y of n x square of n depends upon the past input value. So the system is static because there is no past and future values, and this is also having minus. So minus n minus 1 means it has past values and future also there 2n. So the current value multiply of 2, that's why it's a future input. So future and past is there, so it's also dynamic. And this one is causal and non-causal example. So what is causal? So causal means it's a casual, so human casually known present and past. So those peoples are not casual, they only know future. So like that, the causal system is a past. This is past value and present is there, so this is casual. And this has future value, it is non-casual. And this one is past and present is casual, and this one is having feature one, this is non-casual. Okay, so this is non-casual. So then uh, so determine the following systems: linear and non-linear systems. So this is the example they given. So what is linear and non-linear? So you have to satisfy the superposition principle. So every equation have to satisfy the superposition principle. This is a formula for superposition principle. So we already seen in the previous video the formula. So when in the formula you just applied, then you will be how to prove it left hand side and to right hand side. Then the linear combination of two outputs. The equation 3 and 4 are not equal and superposition is not satisfied. So equation 3, this is the equation 3, and equation 4, this is the equation 4. So it is not uh, satisfied superposition principle. So it is not equal. So when it is equal, so this equation and this equation, when it is equal, then it is satisfied superposition theorem. Otherwise, it is not satisfied superposition theorem. So similarly, for the example, it's the same. And determine the following system is time invariant or variant. Actually, what is time variant? What is time invariant? So time variant and time invariant means so the characteristics of the system is not varied with respect to the time. That is called as time invariant. So if it is varied, it is time variant. So see, there is a time period they given t x of n minus k. So the delay output k. So they just applying. So the system is time invariant. So time invariant means was the characteristics of that system. It's not varied. So the characteristics of the system is not varied because even the time is changed because the input delayed by k inputs. They input is changed, they delayed. So they applied a delayed input, but even the time is changed, the characteristics of the system is not changed. That's why the system is time invariant. So similarly, see the another examples. So it's same like that. See the examples. So input delayed to k input y of n minus k. So here the k delayed input then n minus k. So here just put it minus k, that's delayed input. Then output is delayed by k, y n minus k. So output also getting delayed y n minus k, n minus k. So it is 1 and 2 are equal. So it's a time invariant because characteristics of the signal is not varied. So it's a time invariant. So like that. And finally it's a stable or unstable. So the stable means it has a bounded input and bounded output. If you have the system that is called a stable, it is unstable. So what about bounded values is x of n and bounded output is y of n. So when it is not bounded, then for any bounded values, if it is not a bounded, because n is equal to infinity, y of n is equal to infinity, so it is unstable. So they are saying if it is infinite value of x of n, that is input, and y of n output, they having infinite values, that is unbounded, are not bounded, so that is unstable. Okay, they're having some finite value, that is stable. So x of n bounded, y of n is also bounded, y x of n and y of n, because they are applying n is equal to 0, both are equal, n is equal to 1, both are equal. So similarly here they are applying n is equal to 1 and n is equal to 2. So the x of n bounded and y of n also bounded, so it is stable. So both are bounded. So C v of n, x of n is equal to v of n. So n is equal to n value, y of n is equal to x1 plus v of n is 1. So it is also bounded. Okay, so it's stable and bounded. Okay, thank you.